Welcome back to another one of my applications of differentiation video. This will be focusing on the mean value theorem, and this is the second video. So we'll be looking at another curve on a graph. So, example 1. We have a function now equals x squared minus 4x plus 5 within the domain of half and 3. Okay, and I should have run through the criteria, but I'll do that now. So for us to be able to use the mean value theorem on this function, the function needs to be continuous on the closed interval from a to b. It needs to be differentiable on the open interval of a to b, and it needs to and the function of a can't equal the function of b. If they do equal, then you use the Rolle's theorem and not this one. Okay, and the formula we'll be using, if all three of these are met, derivative of c equals function of b minus the function of a all over b minus a. Okay, so let's find out if all these are met, these first three. If these first three are met, then we do this at the bottom. Okay, so this function here will look a bit like, let's see if I can draw it. So there's our x, and this is our function, or our y values, and it comes in, well, we know that it comes in at a point of 5 because that's the y-intercept, so that's 5, but that's not where we're looking from, but it comes in and does a big loop like that, big curve like that. Okay, so what we're looking at is a half, which is here, and we're looking at point 3, which is about here. And these are our 2 points, and we draw a line through them. Okay, so is it continuous from A to B? Yes, no breaks. Is it differentiable? Yes, there's no changes or sharp points. And does the function of a equal the function of b? Well, this is our a point and this is our b point, and therefore our function of b would be here, and our function of a would be here. Therefore, they're not equal. Therefore, these are all tick, 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 and we use this. What does this mean? Well, this here means the slope of the secant line that runs through both points, which is the f of b minus f of a over b minus a. And we're looking for the derivative of c, which is the slope, which is equal to this, which means the slope at point C would probably be around about here. The slope going through this point is equal to the slope going through this point. Okay, that's what we're looking for. We're looking for a c value that, when put into the function and derived, the slope will be the same as the slope running through the 2 points. Okay, hopefully that makes sense, but this is what we're working with. Okay, so let's get going. Function of x equals x squared minus 4x plus 5. So this here, a value and our b value. So just to clarify, a equals 1/2. Therefore, when we sub this into the function, so function of a, we sub half in where all the x's are, and what we end up getting is 13 over 4, but I'm just going to put that as 3.25. Actually, I'm going to probably keep it as a fraction, maybe look neater. And we have b, which equals 3, and we sub b into the function, so function of b then equals 2. Okay, now we have, therefore all these values equal this, so we've got all we need to put together this side of the equation, now we need the derivative of c. How do we get that? Well, the function of c, we just replace all the x values with c, all the x's with c's. So we end up getting c squared minus 4c plus 5. We derive that to get the derivative of the function of c with respect to c, and that's 2c minus 4. So then we have the function, we have the derivative of the function with c, and we have all of our a, b, function of a, function of b values. So the formula we use, derivative of c equals function of b minus function of a over b minus a. Derivative of function of c is 2c minus 4, and that equals the function of b, we said was 2, minus the function of a, which we said was, will keep us 13 on 4, and all that's divided by b, which we said was 3, minus a, which we said was half. Okay, now we have something we can work with, and we just basically rearrange to find c. So we'll just keep this side the same, and this side here, all that comes down to negative 1/2. And if we add 4 on both sides, we get 2c, which equals 7 over 2. And then we divide both sides by 2, and c equals 7 on 4, or 1.75. Okay, so basically it's saying at that point, at that c, which is at the point on the x-axis, 1.75, the slope will be equal to the slope of the tangent line will be equal to the secant line. Okay, so that's about right, because that's 3, and it's about halfway between 0 and 3, which is about 1.75. A bit, should be a bit over, a bit more, but yeah. So you have at point C, the slope of the tangent line is equal to the slope going through these 2 points. Okay, well, thank you for watching. I hope you learnt something, and hope you have a good day.